All right, it's 5:20. I'm going to be prompt. It's the first time in my life I've ever been prompt. And I'm going to start this presentation. So first of all, thank you for joining. Right, it's 5:20 on a Wednesday. You've endured 2 days of this stuff. So the fact that you're even here, is a bonus. So I probably can count you and give you all each a beer. Couple of disclaimers, right? So this is a talk about, well, in terms of the title, interactive, keyword, that's why it's in bold, load and voltage analytics, which speaks to the fact that we're talking about electrical, energy, right? It has a Databricks twist. The data that's related to this is coming from smart meters, right? That are installed in various homes and industrial spots, and they're looking to optimize it. Why would you want to optimize it? Probably because there's a lot of it, right? So this is a bit of an at scale. This presentation is not the following, right? There's no AI, so no AI, right? It's kind of old school, but there's a lot of data, right? So hopefully you learn a bit about that. Second thing, I'm a non-electrical engineer. So the last time I really dove into this was second year physics, and that's it, right? So I haven't touched this stuff for a long time. Second, I'm not a data engineer, right? So there's some slides on here to speak to Databricks-centric, terminology. Some of you, maybe all of you, are going to know this better than me. Third, I'm not a software engineer, right? So I work for a company called Plotly. Anybody heard of us? All right, more than a few hands, so it's great. So we're known for a lot of different things. Big picture, data visualization. What does that mean? Well, oftentimes it means there's a human in the loop who wants to look at stuff, right? And so it's not strictly back end, and they want to look at stuff, and in this context, they want to do analytics. So that's the preamble. I want to thank a few people who aren't here, right, for affording me the opportunity. One is actually a number of people at Databricks, right, who were involved in this in different ways, shape, or form. I think it's a really good story that's been needing to be told for a while. This was actually originally told in French in Montreal in late November. And I think it was actually warmer there then than it is here today. So, do that what you may. I want to thank Hydro-Québec. They're not here for certain reasons. I won't go into them. But I'm presenting on their behalf today. And so it'll be less technical. This will be speaking more about the why and the when, of how this circumstance arose and the problem set and the resolution, versus so much of the how. So feel free to interject. Hopefully we'll stay on track here. There's nobody following us. So hopefully you'll gain a bit out of it. So with that, I'm going to context switch very briefly, and I'm going to go to this. So this is human in the loop, interactive analytics, right? And what you're seeing on the screen is a chart. It's a chart. It's a line chart. It's got 2 lines, right? They're kind of moving around on the screen, right? I want you to tell me what this means. Any guesses? All right, you got I'm going to you got to speak louder. 24 hours. Okay, keep that in mind, but that's not the answer, right? But you are on the right track, right? And the reason you're on the right track is we're doing industrial IoT, right? So if I look at the next clue on this thing, right here. Oh, my Wi-Fi's off, right? So hold on. Dave's phone. Interactive means you actually have to have network connectivity. All right, here we go. Okay, so time. You got time axis. So good. But that was an easy one, right? The next thing is actually, here's the second clue. The y-axis is water consumption in millions of liters, right? Any clues? Any guesses now as to what this is? Yeah, you're on the track, right? Let's give you another clue, right? So this goes back to your first point. This is during the course not of weeks or months, but of hours, right? Millions of liters, and then some spikes and downs. Any guesses? Irrigation? No. Say again? No, home usage maybe, right? Next clue. Any city in Canada, and 2 dates, February 28th, 2010, February 27th, 2010. No? Oh, all right. Can't be any Canadians in this crowd, right? People going to the bathroom, not during commercial breaks, but during, right, in between periods. You know, when? This event, right? Golden goal, Sidney Crosby, 2010, right? Now, why did I use that? You know, well, that's water, not electricity, right? It's industrial IoT. You know, it's a scenario where unless you actually really know, like, you know, the context and the details, AI is not going to answer it for you. Actually, you know, what I did, you know, was I actually went to, got this off the World Wide Web, as some of you might still call it, right? And it's based on this graphic, which will come up here in a second, from EPCOR, Edmonton Water Utility, right? And they mapped this thing out, right? And then what I did is I fed it into ChatGPT, and I took away all the context and I added it. It did not guess it. It guessed partway through that there was some desalination plant in Perth in 2010 on that date that had some issues, right? But until it got the last clue, you know, it actually told me that there was basically, yeah, this can't be due to like regular usage. It had to be due to some like extraordinary, you know, SCADA system, you know, in event. So why do I bring that up, right? You get these circumstances where AI cannot predict it. You got to be a domain expert. You got to have the context, you know, and then from there you can apply that, you know, tribal knowledge, if you will, you know, to the thing at hand. So, and by the way, there's a hockey game going on for anybody who's kind of interested, from Florida, from Edmonton. So you might want to tell me how it's proceeding. All right, so now I'm going to go back to my presentation and continue it. Am I there? I think I am. Yes. You're seeing that? Okay, so now back to the regular scheduled programming. All right. So this presentation, the feature presentation, is actually, because it's more about the why than the how, it's about this gentleman. And he's probably going to give me grief for putting his picture on the screen, right? But this gentleman's name is Laurie Demers. He's an electrical engineer. He's based out of Montreal. He works for Hydro-Québec, and he actually is like this Renaissance guy, right? He's an electrical engineer who codes, right? And if you look at his LinkedIn profile and you translate it into English, that's basically what comes up on the right-hand side of the screen, right? He's your go-to guy. You got a special project, you want to, you know, get something done, can't quite do it with normal mode operation, he's your guy, right? And who are this protagonist's assets? Well, they're people in the field, right? You know, these operatives, like their field crew, their planning teams, their maintenance engineers, you know, they're getting stuff done, right? You know, in this utility, right? And who do they work for? Well, they're all like these specialists for Hydro-Québec, right? Hydro-Québec, big utility, world's third largest hydro utility, right? For hydro power generation, transmission, and distribution, right? They actually, what's shown on the screen is the world's largest multi-something buttress dam. World's largest dam of some very specific structure. Also, Quebec is a big province, right? Big province. Spatially, it's about the size, a little bit smaller than Alaska. So Alaska's a little bit bigger, right? But Quebec is monstrous. And one thing to note is that when you're generating hydro is often, if you want to generate a lot of hydro, right, you got to have a lot of water. And a lot of those places with a lot of water are a long way away from where the people are. So the generation is a long way away from where the people are. Thus, you need to transmit a long distance, very long distances, right? And so Hydro-Québec doesn't have the longest, transmission lines in the world, but pretty long. And they were innovators back in the 60s of creating, ultra-high voltage AC transmission lines. I learned so much in my job. This is awesome, right? 735 kV AC transmission, like they were the pioneers of this, right? So the Brazilians, and the Chinese, are benefiting from, some Quebecois, innovation, right? Now, the numbers, right? Utilities are like capital intensive, right? Lots of assets on the balance sheet, right? Lots of capital investment, right? Lots of revenue, pretty good income, right? Lots of employees. Those 22,000 employees represent the whole, from generation, right, transmission and distribution, and they, big numbers in terms of terawatt hours of actual, power sales, of which 10%, roughly, is actually consumed outside the province of Quebec. Some a little bit to the west, in Ontario, right, another big province in Canada. Some a little bit south, to our neighbors in the United States of America, right? And these businesses are split into like three big pieces, right? There's the generation part of the equation, right? In this case, it's predominantly hydro. Although if you look in the fine print, they actually, essentially aggregate, renewables or like, people like selling their power to the grid, right? So they're de facto. The transmission lines we kind of talked about. This talk is about neither of those two. This talk is about the distribution, the last miles, the last kilometers, if you will, right, of which there's 230,000 kilometers. Do the math, it's about 140,000 miles, I think, right? Somewhere around there, right? For 4.5 million customers, population of Quebec is about 9 million, so like one of every two, two people per household, so to speak. And, max consumption, sorry, Mr. Jacksonville, it's not, in August, it's in February, right? Winter is the, peak season, right? That's when you want to avoid stuff, because like people will, it's cold, right? And here's the theme of this talk. Like, how does this problem about scale come to actually pass? Well, this talk initially, right, is about a great British word. Any Brits in the crowd? No Brits, right? Bespoke. Bespoke is this great British term for custom, right? You want a very specific, tailored, unique solution for your specific circumstances. One word to describe it is bespoke. And in this particular context, the scene is, imagine the following. You're somewhere in Quebec. It's winter. It's freezing rain, right? Electrical lines are down, right? People's homes are freezing. Why? Because in Quebec, most of the people's homes, 92% of the homes are actually heated with electricity. The rest of Canada and a lot of the US, it's natural gas or whatever else, right? So if the power goes out, you don't have lights, but you don't freeze, right? So it's got a compounding effect. Who are you in that context? You're a line worker, and you're looking to restore power. And as you do so, what you're often offered up by your, management team or whatnot is some app that tells you when you've done your job whether to flip the switch and turn the power back on. And most times it's a yes or a no, basically a thumbs up, thumbs down. But, here's the but. You're a grizzled vet, right? You got fat fingers, you got a hard hat, you've been doing this thing for 20 years, right? And you're not so sure in this particular case, if that yes or no is right, And the thing is, you don't want to just trust it. You're more like Ronald Reagan, trust but verify, right? And so what can you do, so that, especially because you don't want to have to go somewhere else and come back, right? You got too much things on your work order already, and you don't want to have people left in not just the dark, but freezing in the interim. Not a good situation. So here's the what if. What if there was a more sophisticated tool that that person, tailored for you, could take advantage of all your tribal knowledge, right? Maybe not to give an exact better answer, but to give you a better informed answer, in that particular circumstance. So that's the mission, right? Interactive smart meter analytics. And specifically looking at load and voltages. Because it's actually not specifically the smart meter that you're really worried about, it's actually the status of the network in that vicinity, right? And that's and you can inform yourself, of the load levels, of the variance, of the whatever, based on those as inputs, right? And, but also that network is a living kind of organism, right? You got people who have just recently plugged into the grid. You've got transformers that have changed, and so this guy, Laurier, develops this application, to be able to facilitate those users, informing themselves for those circumstances. Now, this is a bit of, a it's not a total corner case, but for dramatic effect. There's more use cases for this for, more mundane planning purposes. But it does speak to when and why these things might be important, right? And so this thing starts its life, not last year, not the year before, 2019, pre-COVID. This story has been a long time in the making, right? And it starts, as many things do, as a classic skunkworks project, right? Hey, I'm gonna test out this theory. I'm gonna pull some data from some smart meters. I'm gonna give it to a few early adopters, and we're gonna see what happens, right? And then remember, this person is not a full stack developer, so he's not speaking full stack JavaScript, React, blah, blah, blah. Yeah, he knows enough Python to be dangerous. So Python for him is a programming language, not a snake, right? But it's not the top part of his, raison d'etre, to use it, a bit of French. And actually the UI here is on the right. It's a static image, so it doesn't really do it justice, right? An application, if you take a picture of it, chances are, if I took a poll of you and we hadn't informed and I asked you what this was, more than a few of you, would call it a dashboard. And I go, no, it's not a dashboard. It's not a dashboard, right? It's an application, right? An application allows the user in there to do more than just view and consume data, but to actually do what-if analysis, calculate, various things, do iterations on that. And so here, I did an animated GIF because I don't have access to the app. It's in a secure environment. I don't have privileges. It's a little bit grayed out, a little bit, fuzzy. Even if it was fully clear, how many people here speak or read French? Oh, none. Well, I could have done it in the clear, right? And you'd be okay. But basically, this is all in French. It's an application. It's a web application, right? And if, the animated GIF comes back and forth, but on the left, there's a whole bunch of filters. You can filter out, whether you want, everything up to 110 volts or 100 volts. So you can narrow down your field of view. And then from there, you can select certain smart meters or transformers or subset of your grid. And then from there, when you pull it, you can pull it back and you can see a year's worth of smart meter data, right? And then from there, because you know what you're looking at, you can see macro variations. Oh, in the winter, it goes higher versus lower. But then you can also see little spikes and this and that, right? And so the person who knows what they're looking at, they can do a lot with this thing, right? So it's a high value application for that niche set of users, right? And just to reinforce, it's a data application, not a dashboard, right? And here's a little bit of advertising, right? How did he build it, right? Well, he's in Python. He used this web application framework called Dash, that's been developed in open source by a company called Plotly. That company called Plotly is based out of Montreal, and he knew about this company back in 2019, right? So he was an original gangster. He was one of the early adopters, of Plotly Dash. And he knew that he could use this for this purpose. Now, Hydro-Québec, big company, right? Hydro-Québec, big Microsoft customer, as are many big, utilities, right? And so Microsoft has many technologies, right? One of those technologies is Power BI, right? Power BI, you can do a lot of different things. And because they're a big Microsoft, customer, there's a dictate, right? Thou shalt use Power BI, right? Unless, right? And so he found the corner case, the unless, hey, I can use Power BI for A to T, but U, V, W, X, Y, and Z, or Z, depending on your proclivities, right? Not so much, if at all. And so he, in Python, used this Plotly Dash web app framework because it afforded him these general kind of characteristics. It was more flexible. It was more interactive. It was more scalable. It was more customizable. It was more actionable, and it provided more of an opportunity for it to be sophisticated. So the expression of pain, because he tried it first in Power BI, was I don't just want a dashboard anymore. I want an application, I want a UI, I want a tool, and, logical and, yeah, he didn't want to hire a full stack dev team, right? Didn't want to go to Accenture. Could he do this thing himself, right? And, this was 2019, so when he did this is pre-COVID. If you look at that chart on the left, that's actually a chart with a what do you call it, like a logarithmic, exponential y-axis. So it shows the increase in use or adoption of this Plotly Dash web app framework over the course of time. So back then, they were on the order of like 100,000 downloads per day. Roll the clock forward 6 years, 5 million plus, per month, right? So lots of adoption in lots of countries. So actually, I have the distinct privilege, right, in my job at Plotly of waking up every morning, talking to people all over the world, doing all manner of crazy stuff. This is one example of such, right? And I know this much to anything about what they do, but they manifest themselves in these circumstances, right? Hey, we use X, but status quo is not working, and so they tend to be these sophisticated, advanced analytics use cases. It's a prime example, right? So let's roll the clock forward. It's not 2019 anymore, it's 2023, right? Okay. Mission accomplished, box office success. This application called Octave, and I asked Laurie, why'd you call it Octave? And he said, well, it's some French acronym that he concocted. He can't even remember why, right? But now he's on a version 2.8. It's an application. You don't version control dashboards. Applications you do. So he's actually got a regimented sequence, like 3.5 years later. He's gotten through COVID, and now this Skunkworks project now has 350 users. Now, remember the total population, like the total head count of Hydro-Québec, about 22,000? I think the number in the distribution wing is about 5,000. So you got 300 of 5,000 using this thing. It's not a bad thing for like a little Skunkworks project, right? And of those 350, upwards of 150 are using it per day. Not for 8 hours a day, maybe for a few minutes, maybe for an hour, and there's a fair number of queries. And now they're accessing the entirety, right, of the network, 4.5 million smart meters. And they have multiple use cases. And they've actually operationalized it. So they actually have to have some like formalization, regimentation. And he's the only guy who's developing it. So it's like, it's a development team of one. So everything should be good, right? Well, actually, plot twist, right? Couple things. One is at the scale on the back end, right? Now you got 4.5 million. Now you got multiple users worth of data. The numbers start adding up, especially in aggregate. And on top of that, because you're operational, there's more scrutiny. Apparently, smart meter data can be used to identify what you're doing, right? Like if you're a retirement home, like your actual peak loads and valleys are very regimented. Who knew, right? And probably if you have a grow up, there's some like characteristics, that you could find out. So, greater scrutiny combined with, right? Quebec adopts a privacy law in 2021, 2022. It's a GDPR kind of equivalent. So, thou shalt, be standard. So for both scale and privacy governance reasons, need to evolve, the overall architecture. Well, we're at a Databricks conference. What do you think the next slide's going to be, right? Enter stage right Databricks, right? And so they take all the data from the legacy, whatever it was that was working reasonably well, which the end users don't care about, right? And they pump it all into Databricks, right? And it addresses the data governance requirements, supports the large volumes, incorporates a really, highly optimized pipeline. They got all these logical functions. They convert them to PySpark. at each stage, they create these intermediate tables, and I'll get into that a little bit more. They partition, they optimize, through memory, their clusters. Life should be good, right? They're doing all the best practices for this particular circumstance. So, what could be wrong, right? Why are we having it? Well, not so fast. Not so fast, right? The end users, they don't care about all that stuff going on underneath the hood. They don't care how the data gets to it. They just want their data 2 seconds or less. It's a classic problem, right? And because if they don't, then they're going to be waiting. Where are they waiting? In a truck? If they wait 15 seconds or whatnot, they're not going to use the application. So it's going to go unused. But let's look at what's happening below the waterline. Lots happening, right? The one thing that I learned, from an appreciation standpoint, is that this topology changes daily, right? I alluded to it previously. New smart meters are getting, plugged in, right? New transformers, other ones. So the dynamics of the network change all the time. And it changes in context with lots more data. And so as the end users want to see the health of the network, they actually run in pretty intensive, computations, to get the state of affairs, right? And they're doing it ideally daily, but they're actually doing it weekly because it's super expensive, right? It's super expensive to do. But despite its expense, it's worth enough time and energy, and expense for the end users to use it. They wouldn't be spending the money on these updates if it wasn't worth it for the end users. And then they have these profiles optimized. So lots going on there. The more you ask about this, the more I'm going to have to defer you to a Databricks, team, or low level. Because even Laurier, who's the electrical engineer, he can understand the symptoms. Had to talk to the Databricks people, to facilitate this, right? So the challenges that persist, one is the fact that despite some of these optimizations that they did from a standard standpoint, the interactions were slow. And they're compounded by the fact that there's more users, right? More users who are using this thing concurrently with more data. So if you look at, if you train your eye on the right, this is actually like a 7-second, 8-second lag, right? And so it might be okay once, but if every time you gotta like wait 7 seconds, it becomes a disjointed experience, right? So he's trying to reduce the amount of time lag, so end users can have this interactive, graceful experience. So they do a number of different things in terms of weekly updates on various clusters. They add certain workers from their pool. And so that's around 2023, after they've adopted. And so when these challenges persist, this is where they go to the domain experts, right? And this guy goes to his mafia, his Databricks account team in Quebec, who treat him really well, right? And they've got really good data engineers, right? And they bring in the specialist, right? And they work and they basically understand what the real world dynamics are, what he needs from a business standpoint to achieve his technical and business objectives, right? Ultimately to reduce query latency, better concurrent usage, but he had to do that all in the context of satisfying the underlying ETL processes, right? And so, they actually did a fair bit of code, analysis of the, not just the app, but the underlying, sequence, in terms of optimizing. So it's a team effort. That's kind of one of the takeaways here. We're not, in a vacuum. You've got your 5 different, customers, right? If you have a center of excellence, you can bring these learnings, to the table. And in fact, Laurie's been very, very generous, right, in terms of, providing opportunity to speak to other utilities with similar symptoms, right? We talked to a utility in Sweden just a couple weeks ago, because they've expressed similar symptoms. Now, there's less obvious solutions. Got any data engineers sitting in the audience? All right, so you're going to understand this better than me, right? So, I can send you the PowerPoint, you can read through this, but these were other steps, right? I don't profess to understand this. I actually asked Laurier, and he deferred the question, right? So I bring it up for your benefit, right? and if you want to know more, I'm happy to introduce you to people who can like speak to the, to the nuance of this. Ultimately, though, at the end of the day, right, the success factors, this is not an overnight success, right? Like this is actually, in some ways, a victim of its own success, right? The Skunkworks project, it's a classic tale, right? And then all of a sudden, it's like baling wire and duct tape up to a certain point, but it becomes so ingrained by these users that now you actually have to make it real, right? And so this has shown that set of technology, that combination of technologies can take you to that destination, right? And so like, that's an important point to note. But nothing replaces domain knowledge, right? Another key point in this is autonomy, right? Underappreciated, especially in big companies, right? He's in a special team, right? He's in an advanced analytics team. He's afforded the opportunity to be commissioned on these types of projects. If he wasn't, right, then you have the classic, we got to give it to the full stack dev team, and they're like super smart full stack developers, right? But they're not domain people. So there's a lot of lost in translation, right? And we're not talking English to French, French to English. We're talking like domain speak, to comp sci speak and back and forth, and I think we've all experienced that, right? Another one is code quality. We're not talking vibe coding here. We're not talking a quick dashboard. This thing has a life, right? And so he, despite this small team, is actually like a miniature, application development team, right? So you got to adhere to some protocol and standards. You got to document your code, do some unit testing, right? And then rely on the people who know what they're doing, right? Databricks, provided like a lot of technical competence, because they've seen some of these things in different ways, shapes, and forms, globally, right? And, from our standpoint here at Plotly, right, he's an electrical engineer. We see web applications, data applications, like that's what we do, right? That's what our people do. So whether it be like UI, UX, like an application doesn't get used if it doesn't look good. It just doesn't, right? An application doesn't get used, if the user experience is not good. And in fact, an application use will be detracted, like people won't trust the math if it doesn't look good, and if the user experience is bad. It'll reflect poorly on the actually underlying analytics. So, we've had the opportunity to help him just make sure like you finesse the details. So, it's a franchise in the making. 2024, 2025 as of May, so a month ago, 1,000 registered users. This guy's continued to develop the application, amongst other things. He's got other projects. This is not his only like iron in the fire, right? He's actually advancing like other use cases where you saw that map, right? That map that had, transformers and it had smart meters. Well, he's actually doing some interesting like network geospatial, topology, mapping, where we can like move the placement of the transformers around, rerun calculations based on the distance and the wiring and everything else, right? And get that into the use of these end users. Stuff that in their regular tooling can't do. And then there's like other things. Now Hydro-Québec is a big company. Big companies move slowly, right? So these so they're just getting Unity catalog into place. And once they do, they will be able to afford themselves a more like recent advances with serverless. But serverless may or may not provide like a nirvana type of thing, because they have so many users all the time that they have a dedicated cluster. It's up and running. It might be a 6 of one, half dozen of the other, type of scenario. There's other things that they're looking at, right? And then some of it becomes a point of diminishing returns, right? Is it worth the cost, right? Because at this point, the users, they're happy, they're satisfied, right? And at that point, that's, we're at a good enough stage. So you don't need to over-engineer the thing at the same time. All right, that's the credits, right? So we've been here 2 days. If you happen to be here tomorrow, we're at the booth, the F612. If you want some more Plotly Dash things, well, you can't see them because they were yesterday. But those three use cases were all like financial services oriented. The last two were actually about real time. So this, scenario, it was, you didn't see like things updating on the screen every second, right? So it's a historical, and smart meters, you know, for those who knows, they don't pump out data at hertz frequencies. You know, it's more like 5, 10, 15-minute intervals, right? So you're not looking like, you know, did it change in the last 2 seconds? But you can use these web applications in Python with Dash, with Databricks for these things. And as you've seen in some of the keynotes, even just today, right, this is where you get into like really sophisticated stuff with OLTP versus OLAP and, you know, using Postgres. And we get to see and experience those types of scenarios. Want any other information? There's lots of different other use cases that are available. Industrial IoT, energy and utilities is like, between that and financial services is probably like the two most common like intersection points, right? Where we see our technology and Databricks used, you know, very well together. And, you know, with that, I got 5 minutes. You got any questions? I got, you know, a little bit of time thereafter. And yeah, not everything works, right? So there's, you know, they tried other different things, you know, and not everything worked in that case. All right. Well, thank you for your time. Thanks for sticking through it. 6 o'clock.